Hi, I'm Justin.
And I'm Michael.
And this is our podcast where we discuss what we find interesting about the intersection of Web3 and digital security as we know it.
Between us, we have years of experience securing digital products and infrastructure, which has led us to be constantly curious about what's next.
Which is what this podcast is about, sharing our journey as we update our mental models for security in the next internet. Okay, welcome back to Not Your Crypto Podcast. This is episode 9. Michael, we're on our 9th episode. Who'd have thought it?
It's still a surprise to me.
Yes,
I
likewise.
Didn't think we'd make it, but
it's a welcome surprise. The title of this episode is same but different, and it's basically a episode where we're going to take a look and compare and contrast effectively OWASP top 10 vulnerabilities that they see in smart contracts against OWASP top 10 vulnerabilities that tend to be seen in web applications writ large. The reason we had this, where did this come from? This was kind of inspired by our 2 security analysis episodes that we did on 2 vulnerabilities, 2 hacks. The NFT one that we did, I think 2 episodes back, and then 2 episodes prior to that one, or 3 episodes prior to that one. We did an episode on MEV Boost vulnerability where we started to realize, some of the technical aspects of these hacks bear quite shocking, so to speak, I guess shocking to me, resemblance to web application vulnerabilities and it was a shock to me given that the tech stacks are so different. So here we are. For those of you that are not security engineers and do not have any understanding what OWASP is. Effectively, OWASP is a reference that most security professionals, be they engineers, architects, designers, it basically is a compendium of vulnerabilities, and they have a top 10, and normally that top 10, your position in that top, or a vulnerabilities position in that top 10 corresponds to how prevalent it is. The position confers also how much of a risk it can be to your application. So they've done a similar one for smart applications. However, I don't think the positioning, I've just been looking through the notes, I don't think the positioning of these vulnerabilities does confer any
you don't think so? Well,
I don't think
so. Like it, eh?
It doesn't look like it. Basically, what I'm trying to say here in my word salad is I don't think where it is positioned in the top 10 confers where it actually, how frequently they have been found. I don't think they have a large enough body of knowledge or experience, given how new the tech stack is. OWASP top 10 for web apps has been revised 3 times, I think, in the past. And so they've got a large enough amount of information to put things in position. But this one, I don't think so. Happy to be corrected. But anyway.
What would you put as the top number 1?
For OWASP, web app.
Oh, no, for smart contracts.
Oh, for smart contracts. Wow. I mean, given the list as it is, I definitely think logic errors, but that's kind of me biasing to where I've made my bread and butter in my career of exploiting applications, because smart contracts are effectively just decentralized applications. And if you've got logic errors in your smart contract, and then you have to update the entire smart contract, I think that should be number 1, personally. What about you?
I think, I probably tend to agree with that. I think it's just a huge category, the logic error stuff.
Yeah.
I was like, I'd put like rug pulls as the number 1. I guess I don't know if that's a logic error. It's sort of like
no, not really. Not really. It's funny because I was just discussing a rug pull earlier today with someone else. Not your keys, not your crypto. And therefore rug, which basically enables rug pulls. I guess you just have trust. Misplaced trust as the first one, which obviously isn't a great look for the crypto scene in general. But Michael, how are you otherwise?
I am good otherwise, I'll say.
That's good news.
A little tired, but I'm happy to be here. And I'm excited to look through these. Do our best kind of grade 10 English compare and contrast impression here.
So I wonder what marks our listener will give us. Okay, so something's interesting with me, Michael. So you're going to have to keep me on point with timing, because I can't see time elapsed or anything. My interface has changed on our app that we used to record this. So as long as you can see and keep a time check to keep us
that sounds
on
good.
schedule.
Do you want a buzzer or no? Is that too much?
Why not? Why not? No, I'm kidding. Buzzer's okay. But you can just be like, right, on to the next one.
Okay.
So the first one is one we've actually discussed before. This one showed up in the NFT hack. It's called reentrancy attacks. We discussed this in episode 6, so that's 2 episodes back, excluding this one. Reentrancy attacks, Michael. What do you remember from those many weeks ago in terms of how it works and what it was?
Yeah. So reentrancy attack or vulnerability. I guess reentrancy vulnerability, whatever, happens when like you have a smart contract. That smart contract makes a call, like a function call, to some other contract, and then when that other call returns to the original contract, it takes some action, like probably updates some state or whatever.
Yeah.
But the situation that can happen is if that external contracts function then itself calls back into your contract and maybe even calls back into the same function that is like currently executing.
Yeah.
It is often possible. Well, I don't know, often, whatever. It's possible to construct that such that like your contract is doing some action kind of more than you expect, or like basically some constraint that you expect to be on that isn't there. So like the most common example is like you have some like withdraw function and it checks that you have like X amount kind of deposited in something and then it has some logic and then it withdraws that amount from you.
Yeah. That's perfect.
If you can kind of like re-enter in between when it checks that you have like X amount deposited and then does the action, if you can re-enter that function and do it again, then you can probably take like this withdraw action kind of more than anticipated because it's not checking before it updates the state. I don't know if that was clear or not.
Yeah, that's fine. Actually, I didn't expect you to give such a clear and concise.
You should have expected that by now.
Yeah, sorry. We're not going to do that for every vulnerability. We'll be here till tomorrow. But
yeah, we have to move on now.
Yeah, we're going to have to move on. But my question to you is, where do you see what similarities do you see between that?
Yeah, I mean, when we went through when we talked about the NFT hack one, like we talked a lot about time of check to time of use. Like if basically you insert in between when you check something and then when you do something based on that check.
Yeah.
That was the most straightforward one to me.
Yeah, definitely.
I don't know if that's an OWASP top 10. Is it?
No, it's not. And the closest I came to it was basically like cross-site scripting untrusted code as well, because you're embedding code from a third party.
I thought the cross-site scripting was interesting, like the parallel there, because it is like, to me there's two sides of the reentrancy thing. There's the side that you're loading untrusted code, which isn't itself necessarily a vulnerability, right? Like that happens all the time.
Yeah.
So there's the like loading untrusted code part, and then there's the like re-entering the function part.
The function.
There's like those two halves of the vulnerability. Both of them have to be there.
Yeah.
And both of them look a little bit different in like standard AppSec world than here. Like here they're very bundled tightly together.
Yeah. And then that's what makes it. So it's almost like a love child of two web app vulnerabilities. And then it gives you the ability to exploit and re-enter the attack. And obviously, because of most smart contract apps having a financial function to them or a financial aspect to them, it obviously lends itself to exploiting things such as buy this thing and your balance, and basically extracting money from a contract or being able to spend money over and over again and extract that money again. Basically exploiting a difference in the known balance versus the cost of a thing and then extracting that. So that was what I saw. On XSS is not in OWASP explicitly.
What?
I think it comes under injection.
Oh, did they generalize it?
Yeah, they generalized it. So basically it comes under injection.
Okay, fair, but that's like basically XSS.
Yeah, exactly, as a catch-all. On to the second one. In the smart contract
we're already behind.
Yeah, I know. I know. Underflow, overflow. So this is effectively a relation to, this is a computer science one as well. Basically, fixed data types for integers. If you say, if you are going to declare a variable as an unsigned integer with X amount of size, that basically limits you to how big a number or how big an integer that data type can hold. And then what happens is if you go over that number, it effectively resets and it basically states a number that is not true. So for those who aren't engineers, the easiest way to look at this or visualize this is the odometer in your car. If you
Well
go
done.
over the amount of, thank you, I try my best. If you go over the amount of digits it can actually hold, it just clocks over to 0. And obviously you haven't done 0 miles or 0 kilometers in North America. So this is actually, again, this one doesn't have a clear parallel in OWASP Top 10, but it can exist in both web and locally hosted apps. Its most obvious exploitation is balances. Again, it's a case of am I able to increase my balance artificially and allow me to withdraw more money from, say, my decentralized exchange account or a centralized exchange account than I actually have, or basically altering the flow of logic or minting excessive amounts of NFTs and things like that. So yeah, that one's an interesting one. The closest I could come to with that is probably looking at the list now. I would probably look at basically insecure design, which is number 4 on OWASP Top 10 for apps. But yeah, basically it's a design pattern because if you're, why are you limiting the size of the integer? Why are you artificially limiting the size of the integer that your variable can hold without anticipating that you could get an overflow or what is known, or an underflow, by the way, because obviously you have negative unsigned integers. Yeah, so that's where I got with that one.
No, I think that's good. I don't have like too much to say. I think like,
yeah,
you know, like the reason why it's not as prevalent in like web land is because we've designed languages to work at a level of abstraction that is above some of these problems, right?
Yeah, so true.
And so it like this vulnerability like kind of went away, and like I don't know, it's gonna be a bit too strong, but it kind of went away, like kind of left the scene of like web security.
Yeah.
But then what's kind of interesting about the smart contract stuff here is like EVM in particular, and like, you know, some of the smart contract stuff generally, it's kind of like, hey, like what if we did like C again, but now it's like on the blockchain, right? And
yeah, with Solidity.
And so you have these like throwbacks to like now you got to worry about like overflows, right?
Yeah.
Like no, I don't think anybody's talked about pointers yet.
No.
But anyway,
it's coming.
So that so like that's an interesting difference between the security work in those two worlds, even though, you know, it's almost like what's old, like there's a what's old is new again sort of thing, or like, you know,
same but different around. Yeah,
oh,
exactly.
Well done. So yeah, I think that's my only call out there. Like these things are familiar. They're not familiar from the web world though. Right?
That's what's weird. That's exactly what I'm noticing, right? So again, I think you're right. I was like, why are these not so much there? Because not as many of them overlapped, but they do overlap with other security vulnerabilities that I'm aware of from locally hosted applications. And I think you're right. They're basically, they've created the language in which they use to express smart contracts is quite low level, and so as a result you're getting these return of these low level vulnerabilities. Number 3 in OWASP Top 10 for smart contracts is timestamp dependence. So this is an interesting one. I'll just quickly give you an overview and then we can talk about it. Long story short, a global variable that represents the current timestamp of the block being mined. Problem is, this timestamp can be manipulated by a miner within a 15-second window. So that timestamp can be controlled. So therefore, if you build anything that needs to refer to that timestamp for whatever reason, gambling or whatever, or any reason, it can be altered by an attacker to do whatever, well, to undermine your control or undermine your function. What do you think of the sound of that at first blush? What does it give you? What does it echo? I know
so the thing it reminded me of was when you're like playing like a video game where like the real time of day matters, and then you just like change the time on your system console to like be, you know, X number of years, like Animal Crossing or whatever, right? Like you're like X number of years ahead and something happens, or you want it to be like the special like Halloween party, so you set your system clock to like Halloween. Yeah. That's what it reminded me of. But it is interesting. Like, so like this is a kind of vulnerability that's getting at like the execution environment is designed to be untrusted. but there are still degrees of trust that are placed in the node. I don't know if node's the right word. You can keep me honest on that. The no, I'll say node.
Well,
We'll
it
go with
would be
it.
the node,
The
because the
node
node
that
would
is,
make the time, because you're proposing a block. So, oh no, maybe it would be the mempool when you propose a
yeah,
block
right.
and then a timestamp is associated with that block.
Oh, I should gloss over more things more
Or
confidently, and then
maybe
this
no,
would
I
go
think it
better.
might be the node that an attacker can control. Yeah. Anyway, go on.
Anyway, there's still degrees of trust that are placed in the execuation environment of the
Yeah.
distributed code.
Mm-hmm.
And this is one of those areas where that kind of bubbles up to the surface, right?
Yeah.
And like within the window, yeah, what you said, 15 seconds or something.
Yeah. 15 seconds
Like
apparently.
15 seconds is a long time.
In
On
again, this is EVM specific, just
yeah,
in
sure.
case any other blockchains get
Good point.
angry. Yeah, carry on.
15 seconds is a long time.
Mm-hmm.
It's a long time of execution.
Yeah.
Like it's a big window to manipulate stuff in. Like, you know, we want stuff to happen fast on the internet, so it's quite a large window. So that's interesting.
Yeah.
I thought I had one more thought about this. You go ahead. I
For me, the obvious similarity to OWASP was, okay, if you're using a timestamp to actually seed anything, i.e., we're going into crypto world now, as in actual cryptography, not just cryptographic currencies, cryptography.
Yeah.
It's very similar to pseudo random number generators. That's kind of where I was going with it. It's like, if it's a weak source, then you're going to from there derive weak numbers, weak seeding phrases or weak seed numbers, and therefore if the attacker can predict what the number was, they can undermine your cryptographic scheme. That was where it's a bit of a reach, but it actually does come up again in the 8th vulnerability. So I knew my reach was actually going in the right direction, but we'll get there. So yeah, that's what it came down to me. But also having source variables that an attacker can control, that's just never a good idea, really and truly. They should never be able to. And this is the thing about, and when we're talking about attackers and users, etc., know that one person can be both things at the same time. So I can be a miner and an attacker of your blockchain network. I can be a validator and an attacker of your blockchain network. I can occupy the seat at the same time, depending on the context. So yeah, that's kind of where I'm like, okay, timestamp dependence. If you're going to do that, then obviously you should have multiple sources. You have a contract. The solution, apparently, the suggested solution, the industrial solution, is to have multiple sources of timestamps to give you a timestamp, so that you cannot have just one person take advantage and exploit.
Yeah. Like, is there like a timestamp oracle or something?
Basically, that's what they're talking about, building oracles on chains. I haven't looked into that as much as I should have, but that's kind of the solution they use.
That's interesting.
So yes, you should do.
Oh, my other thought with all this stuff is like, a lot of times the first example when it's like, oh, what's an example of this, is like gambling.
Yeah, no,
it's like
crazy.
We should probably come up with some better.
Yeah, we
better
really
examples
should.
To pull.
We actually should. But then again, I think that speaks to the use cases that are on chain as well. Yeah. Cool. The 4th one, access control vulnerabilities. This is an oldie but a goodie. Made much hay of this in my career, because it definitely completely overlaps very neatly with OWASP top 10 web applications. Long story short, Michael, it's granting public access to critical functions within a smart contract, and that has a direct correlation to having access control issues within a web app, to my mind. What do you think?
Yeah, I think I mean, it's definitely like very clear parallel, right? Like you have identities that are taking actions in the contract. You almost always want to restrict some actions to some subset of identities. When you do that wrong, there's usually a problem, right?
Yeah.
I think what makes this kind of interesting in like crypto land or like blockchain land is how default public everything is in a way, right? Like like the smart contract code is entirely public, obviously. Like it's published to the chain.
Yeah.
Right.
Yeah, literally.
And anybody can call any function, right? Like functions are kind of default accessible.
They default accessible. No. It depends on the smart contract. Okay. It depends on the blockchain. So there's blockchains I've messed around with where functions are default closed, and then you have to actually open them up to make them publicly accessible. So that's the point that I think this vulnerability is talking about here. Is generally people make the mistake of making their functions default open. Without thinking, does the public actually need access to this particular function, or should it only be called by a contract, or can it only be called within this contract? So that's basically what this is a catch-all for, is can you please remember to put some type of RBAC on critical functions within your contract? Whereas, yeah, and then obviously the parallel kind of breaks down is within web apps, you have different identities calling it different functions, and therefore they should be, again, role-based access control, they should be enforced at the application level, and sometimes they're not. So sometimes you have a control that you think is enforced and it's broken, web app world. Here you have a function that should be by default closed, and it hasn't even been considered. I think that's where the two parallels, that's where they differ, but they're both about people having access to controls or functionalities they shouldn't. Does that make sense?
I think it makes sense. Yeah, I think but let's say that I have a function that I want certain identities, end user identities, client identities to call. Are there blockchains that give me a way, like a native way to do that restriction, or is it always like anybody can call the function, but then within the function I have some gate that's like only this, this, and this? Or is that a research point?
That's a research point. I'm inclined to say it's the former, but it's a research point.
Like, it seems like it's certainly primitive that would be useful.
Of course.
Okay, cool.
Yeah,
that's
definitely a research point. Cool. Next we have front running attacks. Hey, okay, so this is another catch-all, really, when you think about it. We kind of discussed this this is exactly what we discussed in MEV Boost in episode 5. But you have this generalized mempool where all the transactions are waiting to be processed by the global storage, as they call it in most blockchains, which is i.e. the public blockchain. Problem with that is you can see the transactions that are going to be processed because everyone has access to this. Well, validators certainly have access, and miners in the old school terms still have access to this mempool. And if you can see what transactions are coming up, you can see what transactions are going to move markets or inflate or deflate prices of specific assets. And as a result of that, you can basically front run a trade, or you can place your own transactions with higher fees, etc., etc. For me, this had no parallel to anything on OWASP top 10 or even application security in general, be it web-based or local. I don't know. What about you?
Yeah, I mean, yeah, this is certainly a very blockchain native sort of issue. Probably the closest parallel is there's some shared state that lots of actors can inspect to determine what's going to happen. I don't know, the closest probably the threat models in like a data center where you have a bunch of separate entities operating on the same machine. And some of them are maybe able to inspect state by looking at inspect state totally, but able to get some idea of the state of another process that's running by looking at shared resource utilization.
Yeah.
But I'd say that's a stretch, and that's not even a web app vulnerability anyway.
Exactly.
So that's interesting. Yeah. So yeah, I mean, no obvious parallel. The other way though that I think there's no obvious parallel here is we had a fairly large discussion, and I think there is a fairly large discussion about how do you nail down what a vulnerability is in this ecosystem of the mempool, right?
Yeah.
Because in order to say that something's a vulnerability, you kind of have to take some context from outside of the blockchain. Say it's going to move markets, right?
Yeah.
I mean, those markets in a way aren't like a blockchain native sort of concept.
Nope.
So the vulnerability needs to use this kind of known functionality that's here, and then combine it with stuff completely outside of the context of the technical context.
Yeah.
To get to the exploitation stage. So that's kind of interesting too, right? It's combining both on-chain stuff and kind of off-chain stuff, though I don't know. You can also have exchanges that are completely decentralized. So like,
Mm-hmm.
to what extent is that off chain?
Yeah,
Anyway.
that's kind of all on chain, I guess. Yeah, I'm not gonna ramble because of time, but yeah, I agree with that. I think there are some more thoughts on that. Basically, having a technical expression of an abstract idea like markets,
Mm-hmm.
it's the interaction of those two realms where security comes into the fore in my
Yep.
mind. It's always, as we've always said, even in other contexts, it's a case of where two different surfaces meet and the
Yep.
assumptions of each. That's where you have security issues, or that's where you realize security needs to be taken seriously. Okay, moving on from that, we have the sixth issue, denial of service. This is
Mm-hmm.
sixth on the what's top 10 for smart contracts. I mean, this is kind of does what it says on the tin. Resource exhaustion in this case can be gas, CPU, or global storage, rendering the contract unusable. Yeah, long story short, every time you want to transact on a blockchain, a public blockchain, you have to spend gas. Um, and you can basically you can accidentally author your smart contract to consume more gas than it is allowed to, or more gas, basically have a function consume more gas than it should do, um, and therefore the contract gets blocked, or the function gets the execution doesn't work. Basically, it doesn't go through. um, what do you think of this? Is what would be your most obvious parallel for this?
Is there a DOS one? No, eh?
Not under as I go and look at. No. So to me,
Okay.
I did adjacent ones. To me,
Yeah,
it
no,
was
I
like, go on.
no, I was just gonna say, yeah, I think like it's very familiar in the web app world, right? You were saying like some stuff is familiar from other security contexts, but not web apps, like the
Hmm.
overflow, underflow stuff.
Yeah.
But DOS is one that's like, yeah, you would probably say bread and butter web
Yeah.
app security stuff. I think the interesting thing here is like the gas angle. Like there's
Hmm.
basically a new resource constraint.
Yeah.
Like the ecosystem introduces a new resource constraint in gas,
Yeah.
or whatever is used on like equivalent. Um, and so that's a different like target that you might not be thinking about if you're stepping from like the web world to
Hmm.
this world, right?
Long story short, yeah, you have to realize there's another resource that you may not have considered before. So yeah, to me, the most adjacent ones within OWASP top 10 was security misconfiguration or
Mm.
vulnerable outdated components. If you know the specific application within the stack that has a DOS
Oh yeah.
vulnerability,
Okay.
you could probably exploit that. On to the seventh one. No, is this sixth or seventh? Where are we?
One, two,
Sorry, I
three, four,
can't count.
five, six, seven.
Um,
Seven.
Seventh one, yeah. We have logic errors, aka business logic vulnerabilities in the web app world, which the best way I like to describe it is a mismatch between the intention of the application and what the code actually enables. To me, my obvious parallel was insecure design, which is number 4 on the web app list. In business logic vulnerabilities are the most fun for me because no scanner is ever going to pick that up. If you've
Mm.
built an application to express specific functionality, it's normally because that functionality has come from a set of requirements of some problem that needs solving. um, there is always a mismatch between what happens and what was intended. And sometimes that mismatch can be trivial and sometimes it can be devastating. Business logic vulnerabilities, scanners can't pick that up because they don't necessarily know the difference between, or they will never have the implicit understanding of what you were trying to do with this app. They just know this, they're testing the code as to whether it works and whether it works securely within a defined set of parameters. So logic errors for smart contracts, to me, that's why I said at the beginning of the top of the podcast, this would be number one. I imagine can be devastating because it's a smart contract and everything on blockchains tends to be highly financialized, which is obviously a semi-complaint of ours, but we understand its necessity. So if you have a logic error and a contract is able to do something that it shouldn't and it costs money as opposed to just an inconvenience, then we're having a whole different conversation. So logic errors, and you have to be on your P's and Q's basically to make sure that that smart contract is highly correlated to the problem it's trying to solve, or the code expresses what you're trying to solve. Basically, the problem you're trying to solve. Am I making sense?
Yeah, no, totally. I think
Mm-hmm.
yeah, like it's pretty directly parallel. and familiar for
Mm-hmm.
sure. Um, and I think like that kind of meta structure that like what this means is you have some intended design of the thing that is this like kind of platonic like ideal architecture of the thing you've tried to build, and then you have the implementation of it.
Mm-hmm.
And where those things don't match is where business logic
Yeah,
vulnerabilities are, right?
definitely.
So yeah, no, totally. I think that. I mean, that's a huge one, but I don't know if there's too much to say. Say
Yeah, so
more.
much to say. We could do a whole episode on that. Number 8, insecure randomness. This is another EVM specific one. Apparently, Solidity relies on pseudo random number generators to support all types of functionality, lotteries, gambling, number generators, and pseudo random number generators. Anyone who's been in any application security basically within the application security field for any number of time will know, well, even security field, sorry, actually, to be honest, the comp sci security field, you will know that there are many problems. It's quite hard to do true randomness. In fact, the only way you can get true randomness is in nature, like the decay of atoms, if I remember correctly. So emulating that is quite hard. And if you can't emulate that well, very savvy attackers can kind of predict your seed values that you use, that you base functions on to then have outcomes. So this kind of was a throwback to me, was to number 2 again with like, sorry, it wasn't number 2, timestamp dependence.
Three.
Number 3 is so. Yeah, that's what I got. And then for me, its parallel was, again, cryptographic failures in the OWASP top 10, the application security top 10, which is number 2 on that list because it is now the second most popular security vulnerability. But yeah, so they then talk about solutions, like you said, oracles, online on-chain oracles, which apparently are quite hard to do in certain blockchains. Some other blockchains have solved that problem coming up with other clever things. I haven't looked into that too much. But yeah, insecure randomness. That's number 8. Any final thoughts on that quickly? I'm just checking the time and I'm realizing we've taken quite a bit of time.
Yeah, no, that's all good. No, not really. I think you're right about the parallel. It's one I'd probably like to know a bit more about because
Mm-hmm.
I can't like construct in my head right now kind of the threat model of like
Yeah.
somebody taking advantage of X kind of like pseudo random generation or whatever.
Yeah. Fair.
So that would be cool to look into, but yeah.
Yeah, definitely. Number 9, and this one kind of confused me a little bit. I maybe you can help me on this one. Gas limit vulnerabilities. So apparently, each blockchain sets a finite limit on how much gas a block can consume, and if you put a bunch of transactions within a block from a contract, that basically you could misconfigure it in such a way that it consumes more gas than a block is allowed to consume, and that will cause the transaction to fail and lock funds within a smart contract. I was like, I don't see how that's a security vulnerability. Obviously, you can lose funds within a poorly written contract, but I'm guessing that kind of underlines any. That's not really, I mean, that's an issue for all smart contracts. That's not necessarily a security issue. I think that transcends the class of security vulnerabilities.
Yeah.
So I was struggling and I did click through to see exactly what they mean by that. But yeah, I didn't see that's just a poorly written contract that could have a loop, for example, an infinite loop that consumes gas, and therefore the transaction will fail because it exceeds the limit that block is allowed to consume, and then maybe locks your funds in a contract. I don't see how that's a security vulnerability per se. Maybe I'm being silly here, but yeah.
I mean, when I first read it, I was just like, isn't this like one kind of the denial of service stuff?
Yeah, that's
Um,
exactly how I read it.
which I would consider a security vulnerability, right?
I suppose.
Like if you consider the other one, I don't,
Yeah,
to
that's
be
true.
one,
If you
I don't know
consider
why
a
you wouldn't
DOS,
this one. But
then you
then I'm
probably
like, why
consider.
is it different? So like it must be some different angle if it's a separate, like if they're calling it out separately.
Yeah,
But yeah, no, I don't know. I can throw much more light on it.
yeah. I'm looking at the issue now, and I think it's the locking. I think it's basically locking your funds in a contract by default. So that's where it goes one step further than a DOS, really. It's a DOS that actually does something, I suppose. So whereas a normal DOS, the whole thing becomes unusable and you can't use it.
Mm.
This one DOSes and then locks your funds within a contract. So now you don't have access to your funds, I guess. Then the smart contract author then does something. I don't think they could. What could they do to then extract those values? I don't know. Well, actually, if they were the owner, then yeah, they could. If they're owner of the contract, they could just take ownership of it, the funds, I guess. Yeah, that's an interesting one. Again, food for thought. And then the final one, unchecked external calls. This one's interesting. Long story short, where a contract makes an external call to another contract without properly checking the outcome of that call. So I have my contract. Justin's contract calls out to Michael's contract. Michael's contract says yes or no. This can go ahead, but I don't even bother checking whether he said yes or no. I just go ahead. Or your contract fails and it fails silently, and then basically my contract becomes unstable because it's relying on some type of value back from you. The scary thing about that to me is no one talks about validation type thing. It's just, well, I guess unchecked validation. They're synonyms of each other. So yeah, I guess it's basically lack of validation when you're calling in another contract. What do you think?
Yeah, definitely. Like, I don't know that has a direct parallel on the OWASP list, but I think from like a web security or like SaaS sort of security perspective, like, you often deal with calling external services or external parties or whatever.
Yeah.
And it is occasionally important to check to do validation before you take an action on your side.
100%.
Like in a way, it's similar to the reentrancy stuff we talked about, in that like there's like you call out to this external party to do something, and then you proceed as if that thing happened. Like, yeah, you know what I mean? Like then you need to do some validation to make sure that when you proceed, the assumptions that you made are actually there, right?
Yeah, 100%.
So it's similar to that to me, and it feels familiar, right? But yeah, I don't know.
Definitely.
It's listed there.
All right, that's all 10. We've kind of gone over time. Thank you for bearing with us if you did. Any important takeaways? Anything that I think you've kind of hit the nail on the head earlier. I think you went early where you were like, okay, well, to be honest, web application frameworks have basically abstracted away a lot of these vulnerabilities. And I think it's revealing how low level in some aspects these blockchain languages actually can be.
Yeah, like I think I see, like, to me there's like three categories almost, right? There's like things that are a direct parallel, like logic errors. It's like, yeah, right. That's there for sure. There's things that are that have interesting parallels if you in another another familiar security domain, like a non-web kind of paradigm or whatever, like the overflow and underflow stuff, like some of the insecure randomness stuff for sure, and all that. And then there's a third category that is like really seems to be like blockchain native vulnerabilities, right? When we talk about front running, or you talked about gas limits, or reentrancy as well, more or less.
Yeah, basically double spend.
So yeah, those three categories, like, it's interesting to kind of think of those. And when we're looking through even the vulnerabilities we talked about in previous episodes, ones we're going to look at next, like, what world are we in, right? Like, are we in just the web world and like we know this stuff, or are we like, cracking open our like undergrad textbooks to read about bytecode and all that? Or is this really new? Like, is this a new world of thinking through these things?
Yeah, definitely. And with that, I think we'll put a lock on this one. Thank you for listening, and we'll catch up with you in the next episode.
Yeah, thank you.
Bye.